here we go. This is the pre-calculus section 4.5B, second part of section 4.5, instructional YouTube video. So learning targets today are to write the equation for a sine or cosine function from information about a graph. So by looking at the graph, you could just do this with just a few of the points on the graph, and also based on the transformation, so a description of the graph, like a verbal description. All right, so we're going to start off with these two problems, writing a sine function, so writing the sine function equation for this graph and a cosine function equation for this graph. So starting here, a good thing to do with any of these problems is identify amplitude, period, midline, phase shift, kind of our main important features. So the amplitude here, remember, amplitude is the distance from the midline to the maximum, or it's half the distance from the minimum to the maximum. So that means the amplitude here is 2, because this is 4, half of 2 is 4, so that's just 2. Amplitude is 2. The period is the amount of time it takes, or sorry, the amount of time, the x distance it takes for one complete cycle. So if I go, start at the middle, remember sine goes mid, max, mid, mid, mid. That would be one full cycle like this. That means starting from 0, I get to 2. The period is 2. The phase shift, because we want a sine function here, there is no phase shift. We're starting at x equals 0, so there is no phase shift here. And the midline, right, this midline here is y equals -4, which means we are shifted down 4. So to write our equation, we're just going to say f of x equals 2 sine, and that's this 2 here, the amplitude, is our a value. We're going to deal with the period in just a second. And then we have a midline of -4, so we're going to subtract 4. Now let's look at how we use the period to find what goes in here with the x. Now remember, the original period for a sine function is 2 pi. And it's 2 pi over b, where this is bx here, equals the period. So basically we just need to figure out what b is to make this 2 pi over b equal the period, which is 2. So 2 pi over b equals 2. Now we can just look at this one and just like, oh, 2 pi divided by what equals 2? B's got to be pi. Right? Because you'd have to have the pi's cancel out. It's not always going to be this simple, so what we can always do is multiply by b on this side and then divide by 2. So 2 pi over 2 equals b, 2's cancel, b equals pi, which means we have this equation here, f of x equals 2 sine of pi x minus 4. Boom, that's the equation. Got it. All right, let's look at the next one. Here we want a cosine function. Once again, we're going to look at amplitude, period, phase shift, and midline. The amplitude in this case is just 1, which means there's no a value that we write out front here. The period for a cosine, or for any function, is just the x distance of one cycle. So remember, it goes max, mid, min, mid, max. So it's this distance here. You could also look at this. That's one cycle here, right? Mid, min, mid, max, mid. Mid, min, right? It repeats. Right, that is, this distance is the same as this distance, and it's pi. The period here is 1 pi. The phase shift, we are starting either at -pi/4, or we could say we're starting at 3 pi/4, or we're saying we could start at 7 pi/4, or we could start at one of the bottoms, one of the minimum, and have a vertical reflection. I'm going to choose -pi/4. So I'm going to say left pi/4, and then the midline is just y equals 0. That means there's no transformation up or down, no shift up or down. All right, so to write our equation, we're going to say f of x equals just one cosine, so just cosine of stuff happening to x, and then plus 0, so it's just, we just got to figure out what this is in here. And this is going to be our bx plus c or bx minus c. It's going to be a plus in this case because we're shifted left pi over 4, so I'm just going to leave it as a plus. All right, so we can find our b value the same way we did here. We're going to go 2 pi over b equals our period, which is pi. Well, in this case, b is going to equal 2, right? Because if I multiply by b and divide by 2, or sorry, divide by pi, I get 2 pi over pi equals b equals 2. So I have 2x plus something, and I remember 2x plus c, or bx plus c equals 0 when x equals your phase shift. So what I can do is I can replace x with the phase shift, which is negative pi over 4, right? X equals left pi over 4, right? That's our starting point. And I can go 2 times negative pi over 4 is negative pi over 2, plus c equals 0, add a pi over 2 to each side, and I get c equals pi over 2. So there we go. We have our equation there. There's another kind of cool trick that we could use in order to find that phase shift, or to find the c value from the phase shift, sorry. We know we have cosine of, right? The b value is 2. Now what we can do, this chair might be in the way, is I can just go x plus pi over 4. If I have it factored in the argument, this phase shift shows up like it normally would with a general, like a regular transformation. Left pi over 4 would be plus pi over 4. It just needs to have the 2, the b value, factored out of it. So now if we distribute this 2 through, we'll get cosine 2x plus 2 times pi over 4 is pi over 2, and that's the same thing we had there. Cool. So kind of the trick here is look at the graph, identify amplitude, period, phase shift, midline. Amplitude is the distance from the midline to the maximum, or half the distance from minimum to maximum. The period is the horizontal distance it takes to complete one cycle before it starts repeating itself. So you can always find that from a maximum to a maximum, you can find it from a minimum to a minimum, or you can find it by just looking at one full sine curve. So mid, max, mid, mid. So that distance, that horizontal distance, that's your period. Phase shift, you gotta know if it's sine or cosine. If it's sine, find where it starts at the middle and goes up, right? That starting x number will tell you your phase shift. So for example, if I wanted to start here, I could say, oh, it's got a phase shift of right 2, but the period's 2, so like, we just choose 0. And the midline is right through the middle of the graph. Okay, let's do a couple more where we have a description of the function, and that'll be it. So, yeah, let's do that. It's a pretty quick one. All right, here we go. We want a sine function with a period of 10 pi, amplitude of 4, phase shift left 3 pi, and the translation, right, remember translation, shift are the same thing, down 2. All right, so we have these 4 pieces of information, talking about our period, our phase shift, our amplitude, and our midline. That translation is our midline. So we have a sine function. It's going to be f of x equals something sine of something x, and then something, right? Because it's f of x equals a sine of bx plus c or minus c plus d, right? That could be a plus or minus, doesn't matter, right? Just depending on which direction the shift is going. Here, we're going left 3 pi, so we're going to have a plus. So basically, we got to find our a, b, c, d's of this sine function. Well, the amplitude tells us our a value. So here, the amplitude of 4 means we have a coefficient of 4 in front of the sine. The translation down 2 means we're subtracting 2 on the outside there. Right? That shifts that midline down 2. Now we got to talk about the kind of tricky part with the period of 10 pi and the phase shift of left 3 pi. So the period, 10 pi, equals 2 pi over b. Because remember, period equals 2 pi over b. We know what the period is, so we replace the period with what it is. It's 10 pi. So now I just multiply by b on both sides, divide by 10 pi. Pi's cancel out, b's cancel out. All right, we get b equals 2 over 10, which is 1/5. So I have 1/5 x there. Now I got to find my plus c. And it's not just going to be a plus 3 pi. We could do this and then distribute the 1/5 and get plus 3 pi over 5. That would work. Or what we can do is we say we have 1/5 x plus c equals 0. X is left 3 pi, so that means we start at x equals negative 3 pi. So we replace the x with a negative 3 pi, which gives us negative 3 pi over 5 plus c equals 0. Add a 3 pi over 5 each side, and we get plus 3 pi over 5. So f of x equals 4 sine 1/5 x plus 3/5, or 3 pi over 5 minus 2. Notice if I multiply the 1/5 through the x plus 3 pi, 1/5 x, 1/5 times 3 pi is 3 pi over 5. You get the same thing either way you do it. Cool, and that's that. The only real tricky part here is using the period and the phase shift together to find the argument inside the parentheses here. All right, let's do this one. Well, not this one yet. I gotta erase this one, and then we'll do this one. And that'll be it. That'll be it for the lesson. Lesson, video, whatever it is. That will be all. And happy Monday, everybody. Happy Monday at 5 o'clock p.m. Yeah. Although it's probably not Monday at 5 when you're watching this. I hope not. I hope we're doing something a little bit more fun on a Monday at 5. Not that this isn't fun. All right. We now want a cosine function that has a period of 1/2, has an amplitude, let's stop this from shaking, of, let's say, 5. We have a right phase shift, right phase shift of 1/4, so it went 1/4 to the right, and we have a translation up 3. All right, so these are our 4 pieces of information, our 4 transformations that we have. We've got the amplitude and the translation, which tells us about our midline, remember? And then we have our period and our phase shift. So to start it off, we're going to say f of x equals blank cosine stuff with an x blank. The amplitude is our coefficient, it's our a value. Because here we just have f of x equals a cosine bx minus c plus d. Could be a plus, could be a minus. In this case, we're going right 1/4, so it's going to be a minus here. Right, that plus or minus just changes whether or not the shift is right or left. That's it. All right, so this 5, amplitude of 5, tells us our coefficient out front. That's our a value. 5 cosine. The translation up 3, that means shift up 3. That means our midline is at y equals 3. That means we have a plus 3 at the end there. Don't forget to put the plus there. It's not just a 3 hanging at the end. It's a plus 3. We're adding 3 to everything, so the whole graph shifts up 3. All right, now we got to figure out what goes in the argument of the cosine function. So we're going to use the period first to find the b value. So we have that 2 pi over b equals 1/2. We're going to multiply by b on both sides. We're going to multiply by 2 over 1 to undo the 1/2. So we have 2 pi times 2 equals b, or 4 pi equals b. So that means I have a 4 pi x here. And I gotta figure out what that phase shift is gonna be. Or sorry, we know what the phase shift is. We gotta figure out what this 1/4 phase shift does to the c value. So that means we have 2 ways to do this. I could go 4 pi times x minus 1/4 and just distribute the 4 pi through. So it's 4 pi x and then minus pi. Yeah. Or I could say this means we start at x equals 1/4. So we take our bx plus c equals 0. B is 4 pi. X is 1/4. Plus c equals 0. 4 times 1/4 is 1, so this gives me b pi plus c equals 0. Subtract pi on each side, and you get c equals negative pi. Same thing either way. Either of these methods work. They're doing the same thing. So whatever one works best with your brain, use that one. All right, and hey, that's it. Woo, we got it. Woo. So quick recap of these problems. The amplitude tells you your a value. The translation up or down, or the midline value, the y equals number for midline, that tells you what you're adding or subtracting outside. Your period tells you about your b value. It's not equal to your b value. It's 2 pi divided by your b value. So you can always actually do this. You can just go b equals 2 pi over the period value. Right? So you can always just multiply by b and then divide by the period. So 2 pi over period equals your b value. And then once you have that, you can go your b value times x, whatever your phase shift is, and then distribute to get this. Or take your b value, times it by your phase shift, plus c equals 0, and then solve. All right, that's it. Hopefully it helped. Good luck on the homework, and remember I got office hours if you have any questions. Thanks for watching.